The smallest dead star in the universe is barely wider than Earth, yet it holds more mass than our entire sun. A teaspoon scooped from its surface would outweigh a fully loaded truck. It formed from a star that burned for billions of years, and now it just sits there, cooling, for longer than the universe has existed so far. This is a white dwarf, and it is already one of the strangest objects you will ever hear about. Pack the mass of the sun into something the size of a planet, and gravity stops caring about your intuition. A cube of sugar made from this material would weigh close to a compact car. And the reason it does not collapse any further? Electrons packed so tightly they physically refuse to get any closer to each other. Light climbing out of its surface has to fight a gravity well so steep that if you dropped a coin from a meter up, it would smash into the ground faster than you could blink. But a white dwarf is where a star's story quietly ends, not where it violently falls apart. What comes next stops being quiet at all. Take that same collapsed core and give it a companion star to feed on, and you get something that can light up the night sky without warning. A nova can brighten a patch of space by tens of thousands of times in less than a day. It is not the star dying yet. It is stealing hydrogen from its neighbor, layer by layer, until the surface ignites like a fuse. Some white dwarfs do this again and again, decades apart, like a heartbeat that keeps almost stopping and starting over. Keeps stealing mass past a certain point, though, and the fuse stops being small. The next stage is not a flash on the surface anymore. It is the whole star going off at once. Push a white dwarf past roughly 1.5 times the mass of our sun, and it does not just flare, it detonates entirely, all at once, in under 2 seconds. Astronomers use this explosion as a cosmic ruler, because it burns with almost the exact same brightness every single time, letting them measure distances across billions of light years with it. For a few weeks, this one dead star can outshine every other star in its galaxy combined. Here's the part that still unsettles physicists. Nothing is left behind. No core, no remnant. Nothing but an expanding cloud of iron drifting outward forever. If a star like this ignited a few dozen light years from Earth, the light alone could strip away part of our atmosphere before anyone understood what had happened. That is still one of the milder ways this list gets violent. Bigger stars do not need a companion to die this way. Once a star, roughly 8 times heavier than the sun, runs out of fuel in its core, the core collapses in under a second, and the outer layers slam into it and bounce back outward as a shockwave. What is left behind afterward is almost harder to believe than the explosion itself. A neutron star, a leftover core barely 12 miles across, packing more mass than the sun into something you could drive across in 15 minutes. A teaspoon of it would weigh about as much as a mountain. Some of these spin over 700 times every second, fast enough that a point on their surface moves at a meaningful fraction of the speed of light. Spin one of these fast enough and point its magnetic poles just right, and it becomes a pulsar, a stellar corpse sweeping a beam of radiation across the galaxy with the precision of an atomic clock. The first one ever detected was so regular that scientists briefly wondered if it was a signal from another civilization. It was not. It was just a 15-mile-wide corpse, spinning hundreds of times a second, more reliable than any clock humans have built by hand. But even a pulsar is not the strangest thing a collapsed core can become. Some neutron stars are born with magnetic fields so extreme that the number used to describe them stops meaning anything intuitive. Fields a quadrillion times stronger than Earth's own. These are magnetars, and their power is not gentle. One recorded burst from a magnetar 20,000 light years away hit Earth's atmosphere with enough energy to briefly disturb our planet's own magnetic field, from clear across the galaxy. If a magnetar existed just 10 light years from here, its field would be strong enough to wipe every hard drive and credit card facing it instantly, with no warning at all. If dead stars like this already feel like too much, this is a good moment to hit subscribe, because the deaths from here only get stranger, and that is still not the point where a dying star starts breaking the rules of physics entirely. Not every star gets to die on its own terms. Wander too close to a supermassive black hole sitting at the center of a galaxy, and gravity does the killing instead, stretching the star until it snaps apart in a process astronomers call spaghettification. Half the star gets flung outward into space, while the rest spirals down into the black hole, producing a flare bright enough to briefly outshine every other star in that galaxy combined. One such event was recorded still glowing more than a decade later. Far longer than anyone expected a shredded star's remains to keep burning. If our own sun ever drifted this close to the black hole sitting at the center of the Milky Way, it would be unrecognizable within a matter of hours. Sometimes a star does not explode at all. Astronomers have watched massive stars, tens of times heavier than the sun, simply vanish from the sky. No flash, no shockwave, nothing. The core collapses so completely and so fast that even light cannot escape anymore, and the star quietly folds itself into a black hole without ever lighting up the night. One documented case involved a star that sat in observations for years, and then, within months, just was not there. If a nearby massive star did this instead of exploding, we might not notice until someone checked the old photographs of the sky. Some stars, though, manage an explosion even after collapsing this completely, and it is far louder than anything so far. Occasionally, a massive, rapidly spinning star collapses into a black hole and still detonates, twisting into a hypernova far more powerful than an ordinary supernova, punching two narrow jets of gamma rays out through its poles at nearly the speed of light. These gamma ray bursts are so tightly focused that from a distance, they look almost like a laser rather than a light bulb. For the few seconds they last, a single burst can release more energy than the sun will produce across its entire 10 billion year lifetime. If one of these jets pointed directly at Earth from just a few thousand light years away, it could strip away most of our ozone layer in seconds, long before anyone saw the flash that caused it. Some researchers have connected a mass extinction on Earth, hundreds of millions of years ago, to a burst like this from a dying star nowhere near our solar system. That is a death caused by one star collapsing alone. There is an even rarer way to get an explosion this violent. Skip the single star entirely and merge two neutron stars into one. When that happens, the collision does not just release light, it releases ripples in space itself. Gravitational waves that stretch and squeeze the fabric of the universe by less than the width of an atom by the time they reach Earth. And we have still managed to detect them. The same collision forges gold, platinum, and uranium in the same few seconds, which means some of the jewelry on your hands right now was likely born in an event exactly like this. It is one of the only known places in the universe violent enough to make the heaviest elements that exist. Push the leftover core just a little denser still, and some physicists think matter stops being made of neutrons altogether and becomes something stranger. A quark star, where the particles that normally live inside neutrons get crushed so hard they dissolve into one continuous soup of quarks. No one has confirmed a single one exists yet. A few candidate objects are simply too small and too dense to be explained any other way we currently know of. If they are real, a piece of one the size of a grain of sand could outweigh a battleship. And then there's the death that takes longer than every other one on this list combined. A black hole, the endpoint of the most violent stellar deaths there are, is not actually eternal. According to theoretical physics, it slowly leaks energy away through what is called Hawking radiation, shrinking so gradually that a black hole the mass of a star would not finish evaporating for a stretch of time longer than the current age of the universe, repeated more times than there are atoms in your body. Nobody has ever observed this happening, not even once, anywhere in the sky we can currently reach with a telescope. It might be the true final fate of every collapsed star in the universe, the last flicker of a corpse that died billions of years earlier, or physics at that scale might still be hiding something nobody has imagined yet. Every star on this list, from the quiet white dwarf to the gamma ray burst that could scorch a planet from across the galaxy, eventually ends up somewhere on this same road. If this changed the way you think about what a dead star can still become, subscribe, drop a like, and tell me in the comments which one of these you would never want to see up close.